Okay, so here we are. Stack Electricity demos. Making my faces making an appearance for the first time. I know everybody probably excited about that. Truth is this: I have not tested out any of these today. I've done them in the past, but not today. My hair looks huge when I got it flipped on the other camera so I could see myself, which is terrifying. But the reason being, it seems like whatever class has this first in the day, they work for, and then the second class they don't work for. So if I test them all out, I have this feeling that they're not going to work. Okay? So if you watch the video about the charging through conduction, there's like two balls like this. Okay, we might play around with these a little bit at the end and see if we can get them to work. But we're going to do a couple other ones first. But basically the idea of conduction was we had one of these. This is my plastic rod. We put it close, the charge moves, the negative moves, whether towards it or away from it, depending on what this is. Hook it up to a wire, drains off, and then it's left charged. We might try to do that. We might try to start out, I don't know if anybody's ever seen this. Trying to figure out ways to make me feel better, my back and whatnot. Years ago, I saw something called a grounding mat. And this one guy who was in the bodybuilding, whatever, said he used to use these when he slept or when he sits at the desk or whatever. And so basically the idea is, he says, way back when people used to walk without shoes on. Well, rubber is like an insulator. So we walk with shoes now. We build up charge in the body and it can't discharge and supposedly negatively affects you. All right, so they have these grounding mats, and I still kind of should buy one. I don't think they're too much. Where if you ever an outlet, there's three prongs, and the circular one, like in the bottom, it'd be a grounding, and basically you put this in there, and it has a wire, and it's to like a blanket maybe looking thing, or a mat that has like some metal fibers throughout. Obviously the whole putting it in the outlet thing kind of freaks me out, but that's another story. And it's supposed to discharge you because it's going to ground, and grounding you will pull off the negative charge built up on the body, or positive charge. It doesn't really pull off the positive. It actually would take negative to equal out the positive. But anyway, it would pull positive charge off the body and back into the earth. All right, so there's that one, just what it looks like. Now, I haven't done this one too much in class, but I don't know if you can see that. There's two pieces of aluminum foil there attached by a metal rod, and there's a metal ball on the top. I have my plastic. This freaks me out a little bit. Rabbit fur. Okay, I try not to think about it. We could probably use something else. But if you go back and look at the Tribo Electric series, I keep looking up here for the camera. It's right there. The Tribo Electric series, you would see like human hair is towards the positive end, and plastic and whatnot is towards the negative end. So if we do this and we actually rub these together, this one would be negative, this one would be positive. So it should be negative. Now, I can see that there without getting some crazy glare. Is it going to work? Of course not. So ridiculous. Sometimes you'll see them like, they kind of bat it like that. Not working. Typical. I don't know why that wouldn't work. Just trying different things now. We could try to ground it. I'm going to start again. Ridiculous. Anyway, there's two pieces of aluminum foil. If this is negative, okay, the negative charge would be pushed towards the bottom, leaving this net positive, and the bottom thing's net negative, and they would separate because the bottom both would have a negative charge. If I were to go like this and touch it, the excess negative charge would be pulled on or taken by the excess negative charge here, positive charge here, and I could pull away, and then the whole thing would be net negative because it had some extra negative charge from the rod. Didn't work. If this pith ball doesn't work, I'm going to be highly upset. Okay, I watched, if you remember the video, I think we watched a little while back there about the Sumner Miller, and I watched other stuff by him, and he got these things to work fantastic, you know, but that's that. Trying to ground it, doesn't have any charge, probably break it by accident. Okay, so if neither of these have charge, okay, pith ball is basically, I think it's coated in graphite, and it's like a piece of styrofoam, so it's really, really light. So we should be able to see any effects. And I don't know if you could probably see the string. I'm not hocus pocus. But the string acts as an insulator, so we shouldn't have any charge coming from anywhere else. All right, if these are both neutral, nothing happens. Okay? Nothing happens. I should bring it in from the side like this. Now, what happens if I make my rod here, my plastic rod, negative? Okay. I make my plastic rod negative, and I put it up to there, up to this side. It should push the negative charge this way, leaving a positive side and a negative side. Positive side would be attracted, so hopefully we'll see it kind of start to swing towards the rod. We want to make sure it doesn't touch, though. It's so slight. It's not that great. That's terrible. Oh, hair just fell on the floor. I'll try another one. Let's try a different material. Sometimes what you'll be able to see on the rod, if it has some hair on it, you'll see the hair stick straight up. It's because it'd be negative charge and the rod would be negative charge and it's trying to get away from it. It's moving ever so slightly. That's terrible. There's my blinds in my kitchen. Try a different one here. Just a smaller plastic rod. I always use the big one. It works fine. Well, it works the best out of any of them. Yeah, I can see the hair sticking up on there. Oh, there we go. There it goes. Now, in the other video I mentioned, okay, about plastic, we could have a charge build up on here. I talked about rubbing your head with the balloon. And maybe I just rub right here. The charge really shouldn't migrate because it's an insulator. It should stay right in the exact area. So maybe I just need to make sure I charge the entire thing here. Okay. It's moving towards it. It's exciting. Okay? So now here's what we're going to do. I'm going to touch the ball. So, put it close, negative, positive. If I touch it, the positive side will, let's say, take the negative charge from the rod. Then this would be net negative, more electrons than protons. And what's my rod still? There's still going to be excess negative. So if that's negative and this is negative, it should repel. So if this works properly, it's going to come towards it, it's going to touch, and then something should happen. Probably won't work. The camera's there. Here we go. Towards it. It did it. Not as great as in class, but it did it. Now, watch this. Now it's repelling. I don't know if anyone could see that. It's pushing away. It's a little easier to see it that way. So, and if you see this done really well, let's try to ground everything. My hand's probably all messed up. That's probably all. Trying to touch some metal that might be touching something grounded. So it should bounce off. When it hits, it should gather the negative charge. The rod's negative, and it should just fly right off. In class, I've seen it go push and fly off. It's great. Then negative and negative, and then when you put them, it won't be attracted anymore. They'll be repulsive. Hit! Oh, there it goes. Get so excited. And then, oh, that's a good one. Can you see that? Oh, that was really good. You can actually see the angle of the rope is pretty. I gotta do it this way so you can see it better. It's pretty bent. Now here's something else you could do. You remember water is polar, H2O. And I'm not gonna do this, but you can get a little steady stream coming out of a faucet. And if you take a rod, positive or negative, it doesn't matter, and put it up to it, you actually see the water. If it's nice small stream, it'll actually go whoop, and it'll curve. It's pretty awesome. So it's like if it's the rod's negative, the positive side, chemistry, I can't remember right now, but the positive side, the positive side will be attracted to the negative wand. Okay? Pretty slick. Do it one more time. Remember, it's still negative. It doesn't lose that charge because... Well, let's just try to tap it on purpose. Does it do anything? What happened? What happened? It's attached to it now. I don't know. That's okay. Okay, so let's try to do this again. This is way longer. I want it to be hopefully fast forward through some of that junk. See if we can see this. Ready? This is where if we're in class, I go, yeah, you see it? You see it? And I just put it away real fast. So most of the time students will know I'm just messing around. Okay, now what can you do at home to kind of show these things? I don't think, well, my in-laws probably have just rabbit fur laying around. I'm not sure. But and I'm sure you don't have, this is glass, graphite, plastic. Take tape. And I'm going to fold it so I have like a little tab that I could rip off. Okay. Put it on the table. I'm going to do this 4 times. Okay. I don't know why they don't have to be like any particular direction. I'm going to leave it though. I don't want to tear it off again. And we're going to lay them right on top of each other. So you have tape on the table, and you put another piece right on top of it. Make a little tab so you can rip it off. Okay. Now that one's a little bit bigger. I think it'll be okay. No! Stupid. Both fold one on, but I'm just going to grab the top one. I'm not going to grab the other one. Okay. So now it's plastic on plastic. Okay? I'm going to grab the top, then I'm going to take them off. Now if I get them close together, what should happen? Right? They both should be the same charge. Whether it's positive or negative, it doesn't really matter. If they're both the same charge, they should, maybe like this, and they should go apart. Ready? You don't have to pull them at the same time, but I don't know. Here we go. One. Don't let anybody touch it. No kids are here right now. They're hiking on a walk or something. No! It touched my hand. It happens all the time. Pull it off, it goes, and it's attracted to the hand. Now let's take a look here. It's still working. Right? You see that? Ready? Get them close together. Here we go. They're repelled. We don't want to touch. All right. So there that is. We're going to try one more thing. Now this is really just winging it. So, okay, it's charged. It's negative. Okay? Okay. We're going to try a little something here. Here we go. So that's negative. It should still remain negative. I got my ball here. Okay? Insulated here, a conductor here. If it charges, it should stay just like that. So, I don't know if this is going to work. Negative. Now the easy thing would be go up here, touch it. If I touch it, then that should be negative. They should repel. Let's try it. Oh. It attracted. Let's take a look at this one now. Oh, that's really good. Okay. Let's try this again. I'm just not getting enough of like a push here. Just keep doing it. No, that doesn't make it any better. Oh, come on, Matt. That's my name. I don't know. It's doing some turning there. Seems like it's attracted to some part, but maybe not to the other. Anyway, I wish it would have gone away. All right, so now here's what we're going to try to do. All right, here we go. Still negative. Last thing we're going to do. I haven't done much. Put it over here. If you have a faucet, touch faucet or something. That's a good way to ground yourself so you don't have any excess charge. I don't have any socks on either right now. The negative should be over here. The positive, relatively positive here. I hate to say the positive's over here because the positive is distributed evenly because protons don't move. Okay? The electrons can move. So basically what we're doing is just pushing electrons this way. Okay? Now I'm going to try to take them away. How? That's it. Theoretically, push the negative, touched it, pulled the negative off, take everything away, it's positive. Now this isn't really good because it just attracted it before. So like if it attracts it now, you're going to be like, what's the difference? And I totally agree. But it should attract it, okay? Actually, that was pretty good. That's the most attraction we got out of that. See that? It's moving towards it, and then it's moving towards it, and then I'm pulling the thing away. So it worked. I mean, that worked. I think it worked even better that time. All right. So that's like charging by induction and using static electricity to push negative charge around and to move it. Malachi's birthday's tomorrow, the 19th. We'll have balloons out. I'll have balloons out tonight when he goes to sleep. And I'm sure I'll be rubbing it on his head tomorrow. And if you have a balloon, you can mess around and do that too. Another thing about static electricity is that, when you shock somebody, ouch, it hurts. We don't think about it because it's not a big deal. But it's not like it electrocutes you. But static electricity is, tens of thousands of volts. Or whatever, you could look it up. Okay, but the point is it's a huge amount of volts. The fact is, though, the amps, so the current, the flow from one object to the other is really, really, really small, so it doesn't hurt you. Maybe just catches you off guard. All right, well, that's it. First time I made an appearance.